We're supposed to find the pattern and find the next three numbers. It's kind of a famous pattern. It has a name. We'll study it a little bit more later in our course, but the main idea is that you can use two consecutive numbers to find the next one. Add two consecutive numbers and find the next one. So 2 plus 3 is 5, 3 plus 5 is 8, 1 plus 1 is 2, etc., etc. So 13 plus 21 is 34. 21 plus 34 is 55. And 34 plus 55 is 89. If you wanted to show a little bit of work, you could put like a plus 13 here, and you could put like a plus 21 here, and maybe a plus 34 here. That would be some work. This annoying kind of counting problem comes up a lot in our world. How do you know what the 118th one is? Well, you could guess that it's R because R seems more likely than Y. You could try counting it out because 118, it's possible to count to 118, but what if a silly teacher put 11,812 on your test? Do you want to count that high? And the answer is no. So here's a trick, which again we'll explore later in our course, but it's kind of a nice trick. Take these numbers that identify, kind of which position you're at, take them and divide by 3 and record the remainder. So 1 divided by 3 is 0 with a remainder of 1. When we divide by 3 here, we get a remainder of 2. When we divide by 3 here, we get a remainder of 0. And we have a remainder of 1, a remainder of 2, a remainder of 0, a 1, a 2, a 0. So it looks like when you divide these counting numbers by 3 and record the remainder, that the y's happen on the remainder ones and everything else is an R. So we're going to take 118 and we're going to divide it by 3, but we're looking for the remainder. And we're going to get there. The remainder is 1, and so this number, 118, belongs to these numbers, remainder 1, remainder 1, remainder 1, and so the answer is Y. 39A says pick any number, so I'm going to pick 7. And then it says to do some things to it. It says to add 1 to it. So after I do that, I get 8. And then it says find the sum of the new number and the original number. So that means the new number is 8, the original number is 7. Sum means add, so I'm going to get 15. And it says add 9 to this sum, so that's going to be 24. And divide the new sum by 2, and that's going to be 12. And subtract the original number. The original number was 7, so I'm going to subtract 7, and I get 5. And at this point, that's all I know. So let's go on to part B. I'm going to be a little bit lazy here. Instead of doing this over and over and over again like they suggested, I'm going to do it one more time because I want to get on to part D. So let's put in 10. And we add 1 to it, we get 11. We sum those, we get 21. We add 9 to it, we get 30. We divide it by 2, we get 15. We subtract the original number, we get 5. So I think, based on 2 examples, the answer is always 5. So I'm going to put always 5. Now comes the big question. Can we prove that this is true? I mean, what if it's only true sometimes? What if other times it's not true? So let's try putting in a variable instead of a number. And there's no restrictions on that variable. It can be any kind of number at all, not just a counting number. So we're going to add 1 to it. Now we have to remember some algebra. If x is our number, add 1 to it, we get x plus 1. Now we have to add these two together. That'll be 2x's plus 1. Now we have to add 9 to that. So when we add 9, we'll still have 2 x's, but we'll now have plus 10, because 1 plus 9 is 10. Now when we divide this by 2, imagine a fraction bar underneath it. We're going to have to divide that whole thing by 2. And that'll give us x plus 5. And then when we subtract the original number, which we called x, we end up with just 5. The x is canceled out. So the answer is always going to be 5, even if we started with a number like 1.79 or pi or whatever. The answer is always 5. We're supposed to find out why the difference between counting numbers is not always a counting number. If you subtract two counting numbers, you don't necessarily get a counting number. And at first it seems like it's always true. 6 take away 4 is 2. 5 take away 3 is 2. 1,000 take away 4 is something, but it's going to be a counting number. It's going to be on this list. However, what if you go backwards? So for instance, what if you do 4 take away 5? Well, that's not 1, that's -1. And -1 is not in this list of counting numbers. You don't count stuff like 1, 2, 3, and 4, and you don't use -17 in there. It's not a counting number. So here is a counterexample to the idea that the difference between any two counting numbers is a counting number. Now there's all kinds of counterexamples. Anytime you're doing a positive minus a bigger positive, you're going to get a negative, and so you could create an infinite number of examples.